Well, good morning, or good afternoon. It's 12:20. It's supposed to be Calculus 3, Math 227. We're actually 5 minutes late getting started, but I came in here and nobody was in the room, so I took care of a few other things, but still nobody's in the room, so I guess we'll get started. Before I do that, let me get Screencast-O-Matic started so everybody else. Oh my goodness gracious. Well, I guess we're recording, okay. I didn't know that I had hit it. All right. The few, the faithful, the proud. Okay. Glad you're here. I was getting started to get ready to start. In fact, I just turned on the recorder. I don't know if be here if I hadn't done this. Yeah. Skipped over announcements. Nobody's here to hear them.
Two of them at home, and they'll call you back in 20 minutes. Once they get here, now they call me.
Oh, I see. Yeah. That's about how they go, isn't it?
Yeah.
I guess I'll do the announcements, though. I doubt if you're interested in one of the other two, maybe. There is a job offer. And I think I announced it before about the company name is No Kid Hungry, and the job title is Brand Ambassador, and you basically send out items through the mail to the list of orphanage homes that would be provided to you in your city, mail out invitations from us to other non-governmental organizations, foundation businesses to help fundraise, it sounds like. There is a place you can go to find out more information. The weekly wage is $350 a week, and it was from Coach Jefferson. I guess it's one of our coaches here at Lawson. That's what he says. I don't know him personally, so I can't say anything more about it. No deadline on that or anything. I believe that the personal hygiene drive is probably over by now. So I'll throw that one away. And there's also summer research experiences for undergraduates. This one's at UAB, but there's a bunch of others out there. And I would just say, check, I believe on Blackboard, there is a listing of them. It may be on the student suite. Somewhere you can see more information about these, but any that you have any questions about, please contact me and I'll be glad to try to answer those questions. Okay. Now, that's more global type stuff. Let's get specific for this course. Okay. This class is better than my first class as far as getting things in. In this class, 1/3 of you, in other words, one of you has turned in a research paper, which I'm thankful for. But all 3 of you turned in test 1, and 2 out of 3 have turned in test 2. So y'all are in good shape there. I will be giving you the last test, test 3, that last test meaning final test, final exam, but it's not going to be comprehensive. It will just be on chapter 14, what we get covered in that. In 14.2, we'll get as much of this done today, hopefully into 14.3, and then Wednesday as much as we can there. I would like to return all your test papers to you on Wednesday as well. Right now, that's just, I think I've already returned test 1 to everybody because everybody turned it in. So it's just test 2, but I have to have test 2 in before I can return it. So the one person who hasn't turned in test 2, please get it to me by Wednesday. Sooner is better, but Wednesday will do, and I'll be giving you your final exam that day. And that's going to be it. Now, have you seen anything on email about student course evaluations yet? I've asked about it, and I was told they were going to start it, but I haven't seen whether they did or not. You haven't? What's that?
I was looking at last semester, that's what they were talking about.
Oh, I see, yeah. And I imagine they've opened it, but I don't know if they sent the email telling students they've opened it. I'll check, because I asked about that, and I think someone said they were opening it back up. Either that or I saw the title in an email and I didn't get to read the email. But check on that and see if they are. If they are, please do student course evaluations. I forgot to tell my first class that. Okay, if they're out there. I just don't know if they are or not. Okay, let's see. Anything else? I guess that pretty much wraps it up. Okay, any questions on calculus or anything else?
Oh, a bunch of questions. This is way too common.
Okay. Well, my mark is that we're in 14.2. Chapter 14 is multiple integration. 14.2 is double integrations, double integrals and volume. And we're on example 3, which they do not show on the slide set, I don't think. Let me just check and see. For some reason, it's not. There we go. No, they don't do example 3, example 4, or example 5 before they get to average value of a function. So let's go back up here and start the slideshow from this slide. All right. Now, let me get my pen set up. I forgot to bring in my glasses today, so I'm having a hard time reading anything up close. I have to get far back, and when I get too far back, it's too small to read. It's clear, but it's hard to read. Okay. So example 3. No problem. All right. The example 3 we got started on last time, and I imagine we probably need to go back and get it back to where we were, because last time was a long time ago. So let's do it. Find the volume of the solid region bounded by this paraboloid. Z is equal to 4 minus x squared minus 2y squared. Okay? I hope that's a squared. Yeah, to make it a paraboloid it would have to be. And the xy plane. Okay, so xy plane is the bottom, as shown in the figure at the bottom of page 983, which is the page we're on. Okay? Now, so basically, that base is, the xy plane is where z is equal to 0. Okay? So, the volume is from the paraboloid. Now the paraboloid, since the z is positive and 4 minus x squared y squared, if, let's just say we say y is equal to 0, then that would be a parabola that's opening downward about, z X would be the independent variable, Z the dependent variable, and it would be opening downward, okay? And if X were 0, that's still a parabola opening downward. So either the XZ plane or the YZ plane, the parabola is opening downward, so this parabola is opening downward. So then the top would be this thing, and the bottom would be that thing, okay? Where you would be on that. Now, when you set that equal to 0, what kind of shape do you have there? You have 0 is equal to 4 minus x squared minus 2y squared, okay? Well, let's move the two negatives to the other side, and you have x squared plus 2y squared is equal to 4, okay? Now, to make it maybe look a little bit better, let's divide everything by 4, okay? And that would give you x over 2 squared plus y over root 2 squared is equal to 1. And what's that? What shape is that? Yeah, this is, what, yeah, well, this is 2 over 4, so I made it 1/2.
That should be an ellipse.
This is that's an ellipse. You're absolutely right. The major axis being plus or minus 2, the minor axis, the y-axis being plus or minus square root of 2. Okay, 1.414. Okay, so that would be your shape of your base down here in the XZ plane. Now, XY plane. I can't draw these worth of 2, so just bear with me here. Okay, there's negative x, there's negative y, and there's negative z. We don't need the negative z, so I think I'll just take that off completely. It just will do nothing but confuse the issue. Okay, now, if you do a 1, 2 here, and a 1, 2 there, negative 1, 2 there, this is the extent of your x. This is your x, here's your y, here's your z. Maximum z is going to be 4. 1, 2, 3, 4. So that will be up here. That's going to be the vertex, the peak, whatever you want to call it. Okay. On y, it's going to be 1, 2. So it's going to be somewhere about here, and negative 1, negative 2, somewhere about here. 1.414. That's about square root of 2. Okay. So here is going to be your base here. Probably don't have that shape quite right. And then it's going to go up from here to there and up from here. Whoa, that's pretty ugly. Okay, from there. Let me see if I can. This is awful looking, I admit. Okay, so it's a paraboloid. Okay, like that. Now, your really doesn't matter which way you go on this. You can, okay, now here's what my take would be on this. To find the volume of that, and that's what it's asking for, I would just take the first octant here. I think that's how we set up to do before, okay? Because all 4 of these are going to be identical. So I'm just going to take the volume of the first octant and multiply by 4. Okay, but to get the volume of the first octant, now, it just depends on whether you want to do your dx's first or your dy's first. And it really doesn't matter too much which you want to do first and last.
Well, first, and then do dy.
Okay, do the dx first, and then we'll be doing our dy's. So basically, I'm going to do the dy like this, and then we'll be doing the dx's along here, okay, coming out from there. So, let's go back to probably the original form here. X squared plus 2y squared is equal to 4. Okay? Now, if we're doing our dx's, we want to solve this thing for y. Okay? So that will be it just is going to be a little bit nicer to do the dy's first and then the dx's. Have you got any objection to that? Okay, let's do that. All it's going to mean there is flipping this around. Let's just take this is our dx here, and the dy's are going to be the things along in here. And Josh decided to show up today, which is good. All right. Now, since we only have one day left, let me go on and hit a couple things that I said in the announcements earlier. And that is, Wednesday is the last day to turn in the research paper without losing points. So please get that to me today, tomorrow, or Wednesday. Okay? Also, I think I've returned to you test 1, because everybody turned that in. I think I gave it back to everybody. But test 2, I still don't have, so I'd like to have it by Wednesday too, if possible.
Yeah. I got like 2 problems left. Well, differential equation.
Right.
I got to write it all off.
Right. And the reason I'd like it by Wednesday is I'm going to be giving you your final exam on Wednesday, which is the last test on chapter 14. And I'd rather you not have 2 of them out at once. So I'd rather have it in first, just to ease some of the burden off you, because I'll need, and I forgot to mention this earlier, I'll need that last test, the final exam, the test 3, turned in to me sometime the following week. I don't care what day. I'd like to have it Monday through Thursday here on this campus, because Friday I'm on the Birmingham campus, and that means you'd have to bring it to me over there. And I would say, and I will say, you can slide it under my door if you can't get over to the Birmingham campus easily on Friday, final exam week. But then that means I have to grade it Monday morning when I get in. So
when will we turn that in?
Anytime the following week. Yeah. And that's the end of the term, so I can give you an incomplete and wait for it to come in later, but yeah. So that's why things are sort of stacking up sort of heavily here.
Wasn't sure when to come in, I guess.
Yeah. Anytime you want to, I'll be here. Here will be my hours during final exam week. Monday, I'll be here 8 to 6, okay? I don't have any class time in that time frame. I'll be in the office just about the whole time. That's room 265. Tuesday, I'll be available. Well, I'm giving an exam from 8 until 10, basically. So I'll be down in 205 then, but you can slide it under my door if you don't want to come looking for me. Then from 10 until 1:15, I'll be in my office. This is Tuesday. Okay? And then from 1:15 until sometime in the afternoon, I'll be here in this classroom teaching a class. It's the second mini-term physical science class, so we'll be having class that day. And I'm hoping it's just going to be a lab followed by a test. Okay? So it won't take me the whole 4.5 hours that I'm allotted, because it's a mini-term course with a lab. So we'll do the lab first, and then they'll do the test. And then I'm giving them the option of taking their final early if they want to keep them coming back Thursday just to do one test. But that's up to them. So we'll be here from 1:15 until sometime in the afternoon. After that, I'll be down in my office until 8 o'clock, okay? So that's Tuesday. Wednesday, I'll be here from 8 until about 4, because on Wednesday I got to go to the Birmingham East Campus. So I'll be heading over there leaving this campus around 4 to be there by 4:30. I'll be there on the Birmingham East Campus from 4:30 to 6:30. Okay, so that's Wednesday. Thursday, I'll be here. No exams in the morning, so I'll be in my office from 8 until right around 12. No, I'm sorry, right around 1. And then from 1 till they finish taking their test, which won't be more than, I don't think, a half hour for them to take their final exam. I'll be here, and then I'll move back to my office until 8 o'clock that night. So from 1 to, say, 1:30, I'll be here, and then from 1:30 until, or somewhere around there, until 8 o'clock, I'll be in the office. Then on Friday, a finals week, I'll be on the Birmingham West Campus in room B122. That's the academic building, which is the B building, room 122, which is Dr. Carl Pruitt's suite of offices, and I'm in the copy room behind the secretary's desk. They have a table and chairs, and that's where I work on Fridays. I'll be there from 8 to 12. Okay, so that's last day. Now, Monday of the week after that, I'll be here from 8 in the morning until probably 6 in the evening, but grades are due in, I think, by 12 noon on that Monday. So if you do, leave it, slide it under my door on Friday. If you prefer that than going to the Birmingham campus, you can do that. I'll have the morning to grade and then get the grades in and all like that. They have to be in, it's either by 12 or 2 or something like that. But anyway, and then if you don't get them in by there, you've gotten incomplete, but I'll be here Tuesday and Wednesday. Tuesday from 8 to 8 approximately, and Wednesday from 8 to 6:30 approximately. Okay, so I'll be here those last 2 days as well. And then if you do turn something in, then I can change the incomplete to a grade. Otherwise, you'll be waiting until after the new year for me to grade it and get it done. Okay. Any questions on that or anything else? Okay. Bill and I were just discussing, in a very intense discussion here, how we're going to solve this problem. It said, find the volume. This is example 3 on page 983, chapter 14, multiple integration. 14.2 is double integrals and volume. So what it says, find the volume of the solid region bounded by this paraboloid, a really ugly picture of which I've tried to draw here, and the xy plane, which is down here at z is equal to 0. Okay? And so I tried to draw the paraboloid. The shape at the bottom, when you set z is equal to 0, which is the base of this, then you get an ellipse. If you move these two to this side, and then I divided by 4, so it has sort of the standard form of an ellipse. And the major axis is x equal minus the plus 2, y is equal to minus the plus square root of 2, which is 1.414, just under 1.5. So that's how I got the ellipse at the bottom, and then I tried to draw a parabola looking downward. And z goes up to 4, and x is equal to 0, and y is equal to 0, and you have 4 up here. So that's the vertex up there, and then it's a parabola coming down. So we're wanting to do the volume. So what we're going to do is to do a double integral. And the question was whether you do the dx's first and then the dy's, and the dy's first and then the dx. And after just a little bit of thought, I decided it would be better since you have, I went back to this form here, wrote it down again here. This was better for drawing it, in my mind. This is better for solving it, in my mind. It'd be better if we solved for x here and got it in terms of y, so do the dy's first, and then do the dx's last. So I drew my dx here that we're going to do last, and then do my dy's in here. So this represents the dy's. The dy's are going from and I'm only doing the first octave. Because just multiply by 4 and you get the whole life. So I'm going from 0 to this curve here, but when I solve it in terms of y, because no, I'm sorry, we're doing, I'm getting everything backwards here. You get x in terms of y, you're doing your dx's first, and then your dy. So I've got it backwards. Yeah, we had it right the first time, Bill. You were right. Okay. Ooh, it didn't erase it. All right, I lost part of my parabola, or ellipse, or something here. Okay, so we're going to first do the dx's, because you can have the y's as the integral. Okay, so we're first going to solve this, and you have x squared is equal to 4 minus 2y squared, right? So x is equal to the square root of 4 minus 2y squared. Now, you might say, why didn't I say plus or minus here? I'm only going to do the first octave, so I'm only doing the pluses. Okay? So x is going from 0 to some value out here. Okay? And this would be in terms of x equals the square root of, because I'm only doing positive x's here, square root of 4 minus y squared. Okay. And in the book, they're going from minus to plus. They're doing the whole one. I'm not. I'm just doing the positives. Okay? So, the first part of my integral then is going to be from, I kind of like to put in the x. X equals 0 to x equal the square root of 4 minus 2y squared. That shows where I'm going there. Okay? X equals 0 to x equal this point here in terms of y. And I'm integrating this z, because this is where z is equal to 0, so it's 4 minus x squared minus 2y squared. Okay? And this is my dx, because these are the x values, and then my dy is last, and that's going from 0 to the square root of 2. Yeah. All right. We're switching all these dy's in from y is equal to 0 to y is equal to square root of 2. Does that make sense? Okay. Now, so here's your integrand. Now, if you don't like the x equals there, you don't have to write them, okay? If I did that, I probably should have written y equals 0 to y is equal to the square root of 2. And what I forgot to write down is 4 times that, because we're doing just one octave here that's going to be the same volume as that one, as that one, as this one. Yeah. This octave here is the same as that octave here, same as that octave here, same as that octave here. They're just oriented differently, but they all have the same octave. Okay, so let's do our integrations. 4, don't mess with the first one. I'm just going to leave it 0 to root 2. Okay, and let's integrate that first one. What do you get there? dx, integrating with respect to x. 4x isn't it y cubed? I mean x cubed over 3, right? Okay, minus. Now we could have put this with the other one. I didn't, but That's just a constant, right? So it's 2y squared x. Okay? We're evaluating this from 0, x equals 0, to x equal, I kind of like putting the x equals here too, so I remember what I'm substituting this for, x equal the square root of 4 minus 2y squared. I hope that's right. Okay, then finally your dy is still hanging around out there. Okay. Let's do that evaluation first. 4 times the integral from 0 to root 2. Can't do anything with that yet. Now we plug in those values for x. Okay? That's obviously just a square root of 4 minus 2y squared. Agreed? Okay. Minus, now we got to cube that thing, which is itself times what's inside there, right? Because the square would be just what's inside and then multiply it by one more. So that would be, I don't know the best way to write this. I'm going to write it this way. 4 minus 2y squared times the square root of 4 minus 2y squared over 3. Okay? And then the last one is just minus 2y squared times the square root of 4 minus 2y squared. Okay? And then when I subtract the zeros, that's the other advantage of doing octants. I don't have to subtract the negative of that squared. That really gets to be a real pain, but just that. Now, I'm seriously out of room here, but let me bring it up here and put the 4 here, the integral from 0 to root 2 there, and notice here, every one of those terms has the square root of 4 minus 2y squared in it, right? Okay, so let's factor that out, the square root of 4 minus 2y squared, okay? And then what do we have left? Both of these are minuses here. We have minus 4 minus 2y squared over 3 minus 2y squared. Okay, all this dy. Oops. Goodness gracious, y'all let me get away with that? I forgot to write the 1 down for the first term. Okay. Factored out the 4 minus 2y squared, square root of 4 minus 2y squared. Leave me a 1 minus that minus that. All right. Let's mess with this last term here for a minute. Okay? Because those confused looks are...
We multiply it by, like that. If we multiply the 2y squared by 3 over 3.
Okay. That's exactly what I'm going to do next, okay? I'm going to get everything over 3. So this becomes a 3, and that becomes a 6. Okay? All right. Is that all right? Okay. Now, let's see. That's why I say we're going to mess with that last term now. So let's write it down again. 4 times the integral from 0 to root 2. I'm tired of writing it. Okay, times the square root of 4 minus 2y squared. Okay, I'm not going to write it that way much longer. Let's see what this turns out to be. Okay, 4 minus 3 is going to be a minus 1, right? And minus 2y squared minus 6y squared is minus 8y squared, right? Over 3 dy. That's pretty ugly, isn't it? Okay. Um,
We can pull that 3 out to the front.
yeah, you can pull the 3 out with the 4, which is a great idea. Okay.
And we can pull that square root out.
What's that?
No, we can't. Never mind.
What was that again?
Nope, I was wrong.
I
I
can't.
said pull the square root out, but no, we can't do that.
No, it's got a Y in it. They do some sort of magic in the book, and let's see if I can figure out what they did here.
Wallace's formula.
What's that?
Is it Wallace's formula?
Oh, shame on them. Well, that's later. They did a trig substitution before they went to Wallace's formula. Okay?
No, it sure did.
Now, somehow they got they got rid of that 2y cubed over 3. I can see, oh, they did dy's first and then dx's. So back like I had originally thought, but this is a real pain in the neck or some other body part. And it sure should work this way as well as the other way, but obviously it doesn't. There has to be something special about doing the dy's first and then the dx's that makes it a lot easier. Now, they didn't split into octants, 4 octants. That shouldn't matter, okay? But I guess if you had done the other one and done your dy first rather than dx first, they just skipped tons of steps. Oh, wait just a second here. Wait a moment here. What they did, let me back up some. I'm sorry because I realize y'all have written down everything I am, and I'm going to wipe it out in one fell swoop here. Because I think I said at the time, I probably should have done this, but I didn't. Now I'm beginning to say, I really should have done that, okay? Here's what I'm going to do, and this is much, much superior, okay? I didn't notice this. Okay? If we had regrouped these terms here, okay, I'm going to wipe out more, sorry. Why was I so, I just get wrapped up in the moment and didn't look at the big picture. Didn't see the forest for the trees or something, some sort of stupid, well, no, that I wiped out my, okay. Well, okay, that's the y-axis. Here's what I should have done. This is 4 times the integral from 0 to root 2. The integral from x equals 0 to x equal square root of 4 minus 2y squared. Now, look at this. Why didn't I see this? Look at this. 4 minus 2y squared, if I move these two terms together, minus x squared here. Well, this is exactly what's under there. That's where things are going to get better, okay? I sure will hope anyway. So this will be 4 minus 2y squared, if I could write, minus x squared dx dy. Okay? Now, yeah, I think 4 times the integral from 0 to root 2 and I'll do the integration now. This will be 4 minus 2y squared x minus x cubed over 3. Right? Or wrong? Oh, and this is evaluated from 0 to the square root of 4 minus 2x squared. 2y squared, sorry. Right? Okay. So this becomes 4 minus 2y squared times square root of 4. So this is 4 minus 2y squared to the 2/3, 3/2 power, right? This is 2/2 power, this is 1/2 power. Minus this to the 3/2 power here over 3. Right? So that gives me 2/3 of this thing to the 3/2 power. Is that too much talking and not enough writing? Okay. So I'm going to come up here with it. Okay. 4 times the integral from 0 to root 2 of what's in here is 4 minus 2y squared to the 3/2 power, and okay, that's what this is and that's what that is. This is with this plug in, right? Okay, and this is 1 times that minus 1/3 times that, so that's 2/3 times that. So I'm going to pull my 2/3 outside and make that an 8/3. Is that all right? Eight-thirds up front. The 2/3 times the 4 that was there to begin with. Okay? Now this is this now is going to be a dy. So I think ours is even better than theirs. Okay? Now that I've done it correctly. Okay? Now, or smartly, I'll put it that way. The other way was correct. It just was masking what was going on like crazy. Okay. Now, now is where we do a trig substitution. This is one long problem, okay? Because I'm going to have to start erasing things below here too, or somewhere. What the trig substitution is, let y equal to, I'm going to have to stop and do some thinking about this for a moment here. Let me first try to sine theta. I don't think that's right. Sorry. Okay. It's probably I don't know what it is yet, but something like that. Y squared would then be 4 sine squared theta. Okay, 2 times y squared would be 8 times sine squared theta. And that's not what I want, I don't think. So let's try the square root of 2 times sine squared theta. I'm sorry, my chicken scratch is all over the place. This is, I know Bill gripes about this, and I do too. In the book, going from well, he did say x equal, except we're using y, 2 sine theta. I think we have to use the square root of 2 sine theta. Let's just see. Y squared would be 2 times sine squared theta. And then 2y squared would be 4 times sine squared theta. And then 4 minus 2y squared would be 4 minus 4 sine squared theta. And that would be 4 times 1 minus sine squared theta. And that would be 4 times cosine squared theta. Right? Did you follow all those steps?
You start with 4 sine theta or 2 sine theta? Okay. 2 sine theta, right?
Okay. Y is equal to the square root of 2 times sine theta. Okay? What I have here is a y squared.
Oh, okay.
So I first did y squared is equal to 2 sine squared theta. But I have a 2y squared. So that would be 4. 2y squared would be 4 sine squared theta. And then this thing would be 4 minus 2y squared, which would be 4 minus 4 sine squared theta, which would be 4 times 1 minus sine squared theta, which would be 4 cosine squared theta. Okay, so that's what this thing is. Okay? So what we haven't done is what dy is. Dy is equal to the square root of 2 times cosine theta. Okay? So let's go back to what we have here. We have 8/3 times the integral. Oh, and this has a d theta after it. Okay. Now, I'm not going to mess with the limits yet. I will in a minute, I promise. Sort of. Okay, we'll try. Okay. If I can only read my writing now. The 4 minus 2y squared is 4. I'm going to put the 4 on the outside, which makes this a 32. And then this is a cosine squared theta. Okay. And then the dy is another square root of 2. And another cosine theta, so that's cosine cubed theta d theta, I think. Okay. Oh, wait a minute. Nope. Sorry. Let's backtrack most of that. Sorry. Boy, I don't know where to go now. Going to erase most of this. Okay. I think I'm going to erase this too. Okay. What I forgot is this thing here, which is our 4 cosine squared theta. Well, I wrote it down, 3/2 power. Yeah, okay. So it's 8/3, 0 to, well, no, I was going to leave off the units for now. skipping so many steps. Okay. All right. So this thing here is 4 cosine squared theta. Okay? That thing's to the 3/2 power. That's what I forgot to do. And what that produces then is 4 to the 3/2 power. Well, the square root of 4 is 2, and 2 cubed is 8, so that gives me another 8 here. So I'm just going to put 8 squared there. Okay? Get that out of the way. And then this is cosine squared theta to the 3/2. Well, that would be cosine cubed theta. I forgot to do that before. And then my d theta is a square root of 2. So this is 8 squared times the square root of 2 times another cosine theta, which brings me to cosine 4 theta. Ah! Okay. D theta. Okay. Now, how about the limits? When y is 0, that would require theta to be 0, right? Because sine of 0 is 0. Okay? Now, when y is the square root of 2, okay, so we have the square root of 2 is equal to square root of 2 sine theta, and that would be sine theta is equal to 1. So theta would be, supposed to be a theta, it looks more like a phi. That would have to be pi halves. I hope. Is that right?
That makes sense.
Okay. Now, here is where we then use Wallace's formula. Okay? Now, let me see if I've got everything right now. This is going to be 8 squared is 64 root 2 over 3 times the integral from 0 to pi halves cosine 4 theta d theta. Now that looks remarkably, not quite the same, but remarkably like what they had. Okay? Even the same limits. Okay? Now, can anyone remember where Wallace's formula was? We hit it not too long ago, it seems like. But chapter what? 8. Was that where it said? Okay, chapter 8. That must have been my last class we hit it in. Because, yeah, we did chapter. Okay, sorry. In my other class, not too long ago, we did Wallace's formula. And that was in 8.2, I believe. 8.3. Okay. Goodness, you're on top of it. There it is. Wallace's formula. If n is even and greater than 2, greater than or equal to 2, then the integral from 0 to pi halves, which is exactly what we've got, cosine to the 4th power, n is 4, then what you have is 1 over 2 times 3 over 4. Okay? That gets you to your n is 4. So stop with the coefficients then, times pi halves. Okay. So that would be 3 over 16 pi. which is exactly what they got. So we have 64 over 3 root 2 times, what did I just say, 3/16 pi. Okay? Well, 16 will go into 64 4 times. The 3's go out, and that leaves us with 4 root 2 pi. Okay? And please tell me I put something in the place. No, I didn't. Oh, how stupid. Okay, let me go back and find where we are. 14.2. Well, 14.2, there we are. 4 root 2 pi. Goodness gracious. Simple little problem, right? Sorry about this. We're just all over the place there. When you have things like we did here, A's and B's in there with something, and you do a trig substitution, I have to just play around with what the coefficient is to make it come out that you needed a 4 minus 4, sine squared, so you could get that to be 4 times cosine squared. And so that's what we did there. And then you have to do your dy, which got all messed up there because I wrote it on top of that. But that's square root of 2 times cosine theta d theta. Remember, you put that back in for your dy up there. And a lot of the thing that I missed was not putting those two together, because these two together give you exactly the argument of that. That makes the integration much better. And doing the way we did, with the dx's first and the dy's last, much simpler than they did in the book. Number one, in the book, they didn't do 4 times. They did the whole thing, which then you had extra work to do. And then the reason I went with that first was it's much easier to solve for x here than it is to solve for y, because you have root 2. It just is messy. So solving for this first gave me that, and that's a much cleaner form to be doing at the end as we solve. If you look at theirs, they had the square root of 4 minus x squared over 2 all under the square root sign, and a plus and a minus there, and to me that was just extra levels of complexity that were real simple, not that complex, but extra levels there that you could avoid it. And if I had just seen the other thing first, that would have made the whole problem easier. Okay, but anyway, you can do it either way. We've seen it both ways now. That took way too long. Okay, let's clean this and go to, any questions on this before I get rid of it? Yeah. And thank you for Wallace's formula, because that would have been a nasty thing to do without it. I mean, it's doable. We did it before, but I sure didn't want to. Okay.
You ashamed yourself any questions.
What's that?
You ashamed yourself any questions.
Oh, goodness. I have questions. What did I do here? Okay. All right. Example 4. Now, this one, by the way, is at larsoncalculus.com. You can see an interactive version of this very type of example. So it says, find the volume of the solid region bounded by the surface f of xy is equal to, is that e to the minus x squared? E to the minus x squared. Now, the reason I asked, I was expecting to see a y somewhere in it, but it isn't, that I can tell. I don't have my glasses, so it's hard to see. And the planes, z is equal to 0. That's the xy plane, okay? Y is equal to 0. That's the XZ plane, and no, y is equal to x. I've got to graph this thing, okay, and x equal 1. Okay, really nice here, okay. Boy, this is going to be fun to draw. I'm going to do it in my simple little way of drawing. And since we have z is equal to 0, we're not going to make any negatives there. And since we have y is equal to 0, we won't make any negatives there. But x can be negative, so I will extend that one backwards. This, by the way, is x, y, and z. Okay. Now, we're stopping at x equal 1, so let's put that here. And if y is equal to x, then it can't go past 1 either, so that will be there. Okay. Now, f of xy, think of that as z is equal to e to the minus x squared. So z is equal to e to the minus x squared. Well, let's just plot that on the xz plane to begin with. And there we have the xz plane. And when x is equal to 1, which is the maximum value it can have, that's going to be 1 over e, which is about 1/3, isn't it? Somewhere like that. So if that's 1 on z, this is starting somewhere about here. Am I thinking right? Okay. Now, it starts going down towards 0 when x is equal to 0. This is 1. Is it? Yeah. Oh, this isn't going right, is it? Oh, my positive x is this way. My negative x is back that way. That's confusing. Okay. So when x is minus 1, which I guess it can be, but if y is equal to x, x can't go past 0 either. So forget about this, okay? Because y is equal to x, and y can't be 0, so x can't be 0. So basically, okay, we've got a curve that is an exponential increase like that. Right? Do you concur? Okay. And let's just continue this.
The lower the x is, the higher it goes on the z.
Yeah. So it's a curve that does something like this. This is a skateboarding plane. Okay. This is a curve. It's an exponential curve. Mine's not showing too well like that. But there is no y dependence, so the same thing that's happening here is happening here. So this is what you've got going here, I think.
We got that boundary white at
Yeah.
cut off at 1, I guess.
Yeah, you're right. So that would be, there's y is equal to x. So this part wouldn't be there. So this would be going up something like that. So let me get rid of this part. That's what you're saying, right? That one will still be there. I don't think this one will be there either. Okay. Okay. So, oh, I didn't know my eraser was still active. Oops. Okay. Okay, I don't know why. Oh, I know what that was. So let me get rid of that. We don't have anything back there. Okay. So, this is feeling better. Now this is a straight line here. It doesn't look like it's straight, but it is. Huh?
Wouldn't that line be the other way? Or am I just thinking of it wrong?
Well, y is equal to x. Here is x equal 1, y is equal to 1. Oh, you mean coming like this? Yeah, you're right. You're right. So let me erase all this. Well, I thought I was erasing. You're right. I've got my.
I questioned myself though. I was like, well, no, this
No.
because y does equal x.
Okay. Let me. I can't get my eraser to come up. There we go. Okay. Let's kind of start over with. Okay. Okay. I'm even going to erase that one. I'll erase this one too, and I may erase this too. Okay. I'll erase these points. I don't know what they are, but I'll get rid of them. And that one too. Okay. Now, you're right. Y is equal to x. So I'm going to come on to here. So here's the identity function in the first quadrant. Y is equal to x. Okay. Now, this line continues on here and probably down to there. And this is going to be my exponential decrease. And up here, okay, I can't figure out where that one goes. I've got the wrong portion of it, sorry. I'm doing everything backwards. Okay. It's coming out to this one. So that's still my exponential decrease here. Okay. It's actually, yeah. That's starting at 1/3. And then this is, how do they draw that? They draw it like it's a straight line, but it really isn't. Something like that. Now they're showing the curve going the other direction. I just don't see how that would be. But do this. Okay. That's going to be it approximately. They have a different frame. So now I've got a different perspective on it. This is a piece of coconut custard pie that really rose in me, okay? Since we've just been eating like crazy, this is the boundary and that's the slice, and it's just getting really thick over here. Yeah, going up. I think in terms of food better. Okay, that's what we've got here. Thank you for helping me. Oh, only it's in a square pan. Okay, I don't know what it is. Okay. Now, find the volume of the solid region bounded by that surface. So what we have down here is going all right, here's a key for this one. We know our integral. We've got to have a double integral. The integral, the z here, is going to be from 0 to this thing. So it's going to be e to the minus x squared. That's going to be our integral. Now, if you did the dx first and the dy second, there's no way you can integrate that. So that requires you to do the dy first and the dy second, dx second. That way you hope you can get an x in here. And there it's going to be like that. That's where it's going to come from. So we're going to do the dy first and the dx last. So where are our, okay, so the dx last is going to be like this. Your dy's first are going to be something like this, okay? And your y's are going from 0 to x. And then your x's are going to be going from 0 to 1. Right? Does that make sense? This is going to turn out to be pretty, unless I'm really screwed up here, pretty easy to do. So this will be the integral from 0 to 1 of, and since this is the dy, it's e to the minus x times y. I'm going to put the y in front so it doesn't get as confusing. And this, remember, is y is equal to 0 to y is equal to 1. Okay? No, y is equal to x. I wrote it there right, but wrong down there. Wait, no. Sorry. I had it right down here. This is the last one. Okay. This is my x's. X equals 0 to x equal 1. My y's here. This is y is equal to 0 to y is equal to x. 0 to x. What's that?
The x is squared on
Yeah, you're right. Who cares? I mean, no, that makes a big difference. All right. And then the dx is here, right? Okay. Now, that's just simply plugging in an x there. So my integral now is going to be integral from x equals 0 to x equal 1 of x e to the minus x squared dx. And I think we can do that one. Please say yes. How do we do it? How would you do that? Huh? Oh, please say no. Maybe you could. So much easier to use substitution. Let u equal minus x squared. Right? Then du is equal to minus 2x dx, right? We only want an x dx, so let's divide both sides by minus 2. Okay, now this is where things get messy to me. Now we have a minus 1/2 out front, which I don't like. And what we have is a e to the u du, right? Is that right? Okay, and this is going, oops, but we got to fiddle with that now. When x is equal to 0, u is equal to 0. Right? X equals 0, u is equal to 0. When x is equal to 1, u is equal to minus 1. Now we got it backwards, okay? So let's go up here and do this, make this 1/2, the integral from minus 1 to 0 of e to the u du. Now we lost the minus sign, which I feel much better about. And what does that give you? 1/2 of e to the u evaluated from minus 1 to 0. And that would be 1/2 1, e to the 0 is 1, right? Minus e to the minus 1. Right? So I think that's my answer. Now, of course, they would write it some other weird way, which is 1/2 of e minus 1 over e, right? Because 1 minus 1 over e, which would be e minus 1 over e, which would be e minus 1 over 2e. And that's what they got. It's the same answer. And if you're doing advanced WebAssign, they would say,
No, they
this answer
skip
was
all
wrong.
those steps.
And only look for this answer. I don't know how long it would take me. No, that's not the answer I came up with. Is it? That's the answer I came up with. They would say that one's wrong. They would say that one's wrong. And they would only accept that. But of course, all three of them are perfectly correct. Okay. I guess that's a little simpler, but I don't see how. But all three of those are correct answers. And that's approximately 0.316, which to me is an awfully small piece of pie. So anyway, I'm wondering one much bigger than that.
If you look at it as the whole pie is 1,
Yeah,
then you got like
yeah,
a little more than a fourth.
yeah,
Third of it.
yes. So maybe that's not too bad, if it's a big enough pie to begin with. Right,
Yes,
okay.
That's
That's the key, okay. All right, that was example 4. How are we doing on time? We got some time, don't we? Let's move on to example 5. Any questions on that before we leave it? I know I probably did it differently from the way the book did. I'll do everything differently from the way the book did. No, actually, I think we did it pretty close, didn't we?
very close.
Yeah, okay. Yeah, they put the Y, yeah. Yeah. Just coming up with the final answer. Oh, they left the minus sign in there, which is really bizarre. Oh, they didn't even do a U substitution. Wow. Okay. Whatever. I think you doing that makes it a little easier. I know, they just skip a bunch of steps and say, here's the answer. Okay. All right. All right, to erase then? Okay. So let's do example 5. Find the volume of the solid region bounded above by the paraboloid. Thank you for telling us it's above. Z is equal to 1 minus x squared minus y squared. And below by the plane, z is equal to, is equal to 1 minus y, if I'm reading that right. Okay. Okay. Now, let's get our ugly little drawing done. The picture indicates it's all in the first, not all in the first octant. First 2 octants or something like that. It does go to minus x's, but not to minus y's. Okay. Now, we'll put this as a 1, that's a 1, and that's a 1, or something like that. And probably a minus 1 back here. Okay. Now, at z is equal to 0, which they are asking for, but at it is, you have x squared plus y squared is equal to 1, right? So that's a circle of radius 1. So the base of this shape here is a semicircle, okay? That's that parabola onto the base. Now, z is equal to 1 minus y. When y is equal to 0, z is equal to 1. Well, let me go on and draw the parabola here and here and here. Okay, there's your sort of your paraboloid, kind of, in a sense. Okay, z is equal to 1 minus y. So when y is equal to 0, z is equal to 1. When y is equal to 1, z is equal to 0. So this is a line like that. And then it comes this way and that way, this way and that way. But it's intersecting too many lines here. this is a plane, okay, and it's intersecting some portion that goes like this and like that, okay. Now, so it's underneath this paraboloid shape, but above that plane shape, okay? Now, the way they've drawn it, it looks a lot like an ellipse, but I can't swear that it is an ellipse, okay? And I don't think it really matters what shape it is. What's important here is that we decide what to do first, okay? Now, the intersection here and there, wherever it is there, that intersection there is where this D is equal to that D. Okay. So I think you have to set those equal to each other somehow here to get it to work. Okay?
Couldn't you just subtract it?
What's that?
Couldn't you just subtract the double integer?
Right, that's exactly what we're going to do. And maybe we don't even need to worry with where the points are equal, but let me see. I think they do.
Well, to get where you're integrating, I guess.
Yeah. So you're right. You're going to have two integrals here, okay? One is going to be, yeah. Project this all onto the, down here in the XY plane, because that's as low as it goes. And I don't know what shape that's going to be, but it's going to be something down there when that projects downward. I probably haven't drawn it very well at all. Probably not nearly that fat. Okay. And you're subtracting, you're absolutely right. You're subtracting what's under the paraboloid minus what's here. But you have to know how far to go on X. Because you see, you can't do the whole plane because there's a lot under there that's not under the other. Okay. So you sort of need to know that thing. So let's see what happens if we do that. If we do 1 minus x squared minus y squared is equal to 1 minus y. Okay? Where those two are equal. I can get rid of those. I think I'm going back to the other side and saying this is x squared plus y squared minus y is equal to 0. Okay. And if you solve that for x, that would be x squared is equal to y minus y squared. And you have x is equal to plus or minus the square root y minus y squared. And that's, I think, what they do here. I just can't read my book, but I think that's what they do. So you're going from plus this curve here is y minus y squared, and this curve back here is, the square root of y minus y squared, and the curve back here is the square minus the square root of y minus y squared. Okay, so that's your dx. Yeah, that's what your x is equal to, going from and to. So you're going to want to do, goodness, my nose itches like crazy. So you're right in that you're subtracting 1 minus x squared minus y squared. Okay. dd, we got to figure that out, minus the double integral of 1 minus y dd. Okay, we just got to figure out the order. Okay. Now, since you want this first one to be from minus the square root of y minus y squared to the square root of y minus y squared, and both of these minus the square root of y minus y squared, this is square root of y minus y squared. So obviously this is the x is first and your dy is last. Okay? The x first, dy last. Okay. Now, what are the y's going to? 0 to 1. Hey, good to see you.
Now, how did you get that? They don't show it either. I can't seem to solve that.
Say again?
I can't seem to solve that for the 1 and the 0.
Okay.
Does it say it in the problem?
Y is going from 1 to 0 here. 0 to 1. Is that what you mean?
Yeah.
Okay. Yeah. Okay. What you're doing is we're doing strips like this. X is going from minus this thing to plus this thing. Okay? And then the Y is going from 0 to 1. Because in our original setup here, this is a paraboloid with z is equal to 1 when x and y are 0. And this is going to 1 here, because when z is equal to 0, yeah, y is equal to 1. And we're not doing the backside. Yeah, okay. So y is going, has to be going from 0 to 1. Because you're going to the, we decided we're going from the xy plane up because the plane cuts like this. So. Okay. So you got that part. And the other part, you just have to have that because that's what your x is going from, plus or minus of that. And that has to be these increments here from minus to plus of that square root. So that has to be the x first, dy then 0. Okay. Now, yeah. I'm sorry. Next week. Okay. Let me, I just was going to stop right here since we got that question answered. Say this. Okay, remember, I've said this many times, your research paper is due by Wednesday. Okay? You've already turned in the first test. I hope I gave it back to you. Okay? The second test is due by Wednesday. You have that one too, right? Okay. And then on Wednesday, I'll be giving you the third test, which is just what we get to cover so far. By Wednesday in chapter 14, which is what we're on now. And right now, we're only in the second section, so hopefully by Wednesday we'll get at least to section 3. Okay. But whatever we get to cover. Okay. And then it's due, I'll give it to you at the end of class on Wednesday, and then it's due back anytime Monday through Friday of next week. Okay, and Monday through Thursday I'm here on this campus, basically 8 to 6 every day except Wednesday when I leave here at 4 to go to the other campus, just like I usually do. So it's, and actually I'm here at 8 to 8 on Tuesday and Thursday, so even longer, but 8 to 6 Monday, 8 to 8 Tuesday and Thursday, and 8 to 4 Wednesday. I'm on the Birmingham West Campus on Friday, 8 to 12. Okay, now, I've got a test in here, 8 to 10 on Tuesday morning. I've got a class in here, 1:15 till probably, it could be as late as 7:45, though I doubt it, on Tuesday. So if I'm not in here from 1:15, I will be here. Now, I doubt if it'll be more than 2 hours, but anyway, 1:15 to something like 3:15, 3:30, something like that. I'll be in here giving it, we're doing a lab and a test. And then Thursday, I'm in here giving a test. And that'll be probably 1 to 2 o'clock, no more than that. And otherwise, I'll be in my office. No, I'm sorry. The Tuesday morning, 8 to 10, I'm down in 205, not in here, 205. But if you want to turn in something, you can slide it on my door in my office. You don't need to find me. I'll find it when I go back to my office. If you have questions, you'll have to find me. 205, 8 to 10 there, 1:15 to whatever in here. 265 is my office. Yeah, I'd say 1 to 2 pages. Shoot for 1 to 2 pages. Okay, something more than 1 page. All right, we're doing this example. We've got it set up now. This is example 5, top of page 985. I didn't wear my glasses today, so I'm having trouble seeing. So let's do this first integral, the dx one. Okay, so what will that be? And again, I think what I'm going to do, as I didn't do last time, let's change this to 1 minus y squared minus x squared. So we can do the 1 minus y squared by itself and x squared. Because this is not dependent on x, that one is. So the first integral, the outside is 0 to 1 with a dy at the end. So what is the integral of that with respect to x? Let's do this one here. 1 minus y squared times x, right? Minus you see what I did? Okay. I rearranged this to get my x's by themselves and my non-x's by themselves. So I rewrote this as 1 minus y squared in parentheses, because that has no x dependence, minus x squared. That does have x dependence. So when you integrate this, it'll just be 1 minus y squared times x. Okay? Minus x cubed over 3. I may be slow, but I did learn. Okay? And that's evaluated from x equal minus the square root of y minus y squared to positive the square root of y minus y squared. Time out just a moment here. Why am I doing this? Because this half is the same as that half. Let's just double and do 0 to that. Okay? So let's put a 2 in front here and make this a 0 there, a 0 there, okay, and a 0 there. Okay, I need a 2 in front there too. Sorry. Why didn't I think of that earlier? Why do it twice? Okay. Okay. Now, I thought that was going to help us. It really isn't. Okay? That I can see right yet. Okay. I haven't even written the second one. I'll do that later. So we're just doing this first one now. So x is this. So I think that one's going to be 2 times the integral from 0 to 1 of 1 minus y squared times the square root of y minus y squared. So it's not going to help us this time. Then we're going to have a dy. Oops, I've left off the other one. Yuck! Minus y minus y squared times the square root of y minus y squared. That's the y cubed, and that's over 3. Sorry about that. Okay. This is getting really ugly, right? Admit it. It is ugly. Okay. Yeah. All right. Now what I'm going to do here, I'm going to try to make this look a little better. This one that we just wrote down is 2 times the integral from 0 to 1. Here's a 1 minus y squared times the square root of y minus y squared, right? Minus okay, this one is going to be x cubed, this thing cubed, right? So that's going to be y minus y squared times the square root of y minus y squared, right? All right. Now, huh? Over 3. I'm sorry, I didn't put it over 3. Okay.
I get it now.
You got it. Okay. Now, we can factor out the radical here, and that means you subtract these. So this will be a 1 minus y, and this will be minus y squared plus y squared. So that gives you just 1 minus y times.
Wouldn't you have to multiply that by 3 over 3?
Yeah, 3 times this one. But factoring those things out, then this would be a 3, I'm sorry, you're right, 3 minus 3y squared, this is plus y squared, it's 3 minus y minus 2y squared. Okay.
Yeah, I definitely look at it.
Yeah.
Yes, it is minus
3
y squared.
over 3, okay. All right. So, what does that one become? This gives you 2/3, no, it doesn't give you that. It's 2 times the integral from 0 to 1 of 3 minus 2y squared plus y squared is minus 2y squared. 3y squared minus plus y squared is 2y squared, minus 2y squared. I can't even talk. Minus y. Now, I probably should rearrange that. And this is times the square root of y minus y squared. dy. Now,
We
that,
can move the 3 to the front.
yeah, that's what I meant to do. Yeah,
I think we made it harder.
I do too.
We changed it to 0.
Did we?
I'm not positive, but I've got a feeling that we'll cancel out. Maybe
Okay.
not at this point. I don't know.
Well, where did they get? I'm having trouble seeing. No. What I was wanting to do to begin with, because they did 2 integrals and you said 2 integrals, they combined these 2 of these. Because they're going to work out the same. So, I'm sorry.
Oh, gosh.
Yeah. Okay.
I knew you did that.
Yeah. Let me go back. It's all not wasted, but just to keep, I'm sorry, this has not been a good day. Is this Monday after Thanksgiving or something? What is it, Cyber Monday? I'm not very cyber, am I? Okay. I don't feel at all cyber. I feel sort of sad. Okay. All right. All right. Let's see what we can do with combining these 2 integrals together. 2 times the integral from 0 to 1, integral from 0 to the square root of y minus y squared. And then let's take the difference between these 2. This one minus this one. Minus 1 plus y. Okay? that would be, the ones go out, and you have y minus y squared minus x squared. That's your new integrand. Y minus y squared minus x squared. Okay? And you had the dx first and the dy last. Okay. Now, let's combine these two together. See, this is where the magic happens. We're doing the dx, and this is a lot like the previous one we did, badly as well, is 2 times the integral from 0 to 1. How are we doing on time? We're way over, aren't we?
Yeah, 5 minutes.
Okay. But you see, this is going to work out relatively well, because this is going to be y minus y squared times x minus x squared, or x cubed over 3, right?
Almost everything will cancel.
Yes. And then this will be a dy at the end. Well, dx, dy. Well, wait, no. Yuck. All right. I'm trying to skip too many steps here. This is going from 0 to the square root of y minus y squared, right? Now, when you plug that in here, you get y minus y squared times the square root of y minus y squared. And when you plug it in here, you get y minus y squared times the square root of y minus y squared. And this is 3 over 3, so this will be 2/3, so this will be 4/3, 2 from that was there before, of that. Let's see, I've just done too much at once. 4/3 integral from 0 to 1 of y minus y squared to the 3/2 power, right? dy. And there you do your same cosine. I mean, you do the same thing. This is almost exactly what it was before. It's a cosine substitution, just figuring out what the theta is. And it's see, we're right now at the same place they are. And I mean, okay, what they do, yuck. All right, I'm going to have to do a bunch of erasing here, okay, to show you what they did. So, I don't think we need this anymore. I hope not anyway. I'm sick and tired of it, okay. But this is what they got. This is the same step they have in the book, okay. Let me just do all this, okay. Because they just do it and don't tell you how, okay. All right. All right. 4/3 integral from 0 to 1. Okay. And they've got y minus y squared. I'm not sure I'm doing this right. To the 3/2 power, dy. Okay. What they're going to do here, what they've done here, and it's It's just kind of totally bizarre. I'll tell you how I would do it. I would make this minus y squared minus y. Okay, forget about the 3/2. Let's just deal with that. Let's complete the square. That would be minus y squared minus 1/2, or sorry, y minus 1/2 squared. Okay, what does that give you? Plus 1/4, I think. I mean, maybe minus, let's see. So if you square this, you get y squared minus, I think this is a minus 1/4. Okay. Okay. You get, if you squared this, you get y squared. Twice the product of those two is minus y plus 1/4. Then subtract 1/4 and you got the same thing you had. Okay? You agree with that? Completing the square? You'll say yes to anything, won't you? Okay. Okay. Now, let's rearrange it again. And this gives you a minus, this will be a plus 1/4 minus y minus 1/2 squared. Right? Okay. So, let's factor out a 1/4 from that. I don't know. I think that's how you get started on it, but that gives you 1. No, 4 times. Factor out a 1/4, that's divided by 1/4, 4 times y minus 1/2 squared. If you multiply that out again, that would be y squared minus y plus 1/4. And that would give you 1/4 out front, 1 minus 4y squared minus 4y plus 1. And then they say, well, lo and behold, that's also two y minus 1 squared. So they do get that. If you did this, factor out the 1/4, multiply this out, multiply that by it, then you wind up this giving you exactly that. Now there may have been an easier way to get there, but that is the same thing. Okay. So now what you have is, and that's where the 1/4 comes out. Well, they have a 1/8. I haven't figured out where they got, oh, because they haven't done 2 times. Okay. So we get a 1/4 out. Okay. And then this is your trig substitution. Let this be theta. Because then 1 minus theta squared is, does this equal cosine theta? Sorry. Or sine theta. This thing equals sine theta. sine theta equals that, then this will be 1 minus sine squared theta, that's cosine squared theta, and do your d thetas, you get another one, and you get the same thing that we did with Wallace's formula. Okay. Do we want to pick this back up next time, or are you through with it?
I get the gist.
Huh?
I get the gist.
Okay. Is it just enough though? Is it? Okay.
That's gonna help me with another problem that I can figure out the other day.
What's that?
The completing the squares will help me figure out another problem
Yeah.
I was having trouble with.
Right. And that is sort of a standard thing. So let's begin next time. Do you want to go back and finish this next time? I'll be glad to.
I'm always willing to go over.
Okay. Let's try to do that quickly next time. We'll try to pick it up from, where's my pencil? I know I had one at one time or another. Well, I've lost it. I'll put it back in the drawer. That's where I lost it. Okay, we're picking this up from somewhere down about there. Okay. And we'll finish example 5, then do average value of a function, which is very quick and simple, I hope. Okay. And then we'll do the homework exercises you can do now. 3 or 5, they're both at Calc Chat. 3 is at Calc View. Any of the odds, 7 through 11, they're all at Calc Chat. 13 through 19, they're all at Calc Chat. 13's at Calc View. Any of the odds, 21 to 25, they're all at Calc Chat. 23's at Calc View. 27's at Calc Chat. 29 to 33 are at Calc Chat. 35's at Calc Chat. 37 or 39's at Calc View. 41 and 43 are at Calc Chat, but they say you need technology, so see if you can do it without it. 47 to 49 are all at Calc Chat. And stop there because that's the average value from there on. So we're going to finish 14.2, promise, and then move on. We're not going to do 14.3. Okay? We'll move on to 14.4. 14.3 is change of variables, polar coordinates. Unless you think you need that, I don't particularly see a huge value, but if you think you do, to me somehow center of mass is something you're more likely to need.
Sounds like, yeah.
Okay.
I think we've actually gone over that in physics.
Which,
Center of mass.
yeah, I bet you have. And you'll probably go through it in statics or dynamics as well. So you're going to have it several times. So we'll try that one. And if we can get into surface area, we'll try that. I don't know that we'll get there. I'd love to get the triple integrals. They're just like double integrals. You just do them 3 times. Yeah, rather than twice. So unless you think we ought to do triple integrals, we'll go from there straight to there.
Maybe it's just this with another one.
Yeah, you just do it again. Yeah. All right. Went way over. Supposed to be an hour 40, went an hour 53. But guess what? There'll be no extra charge. Okay. So you get it as a freebie. So let's end this.